Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know. Right? I hope my voice is audible to you. Let me have a check also. 1 second, brothers. Right. Okay. Let me have a direct look here. Uh, this YT session. Yeah. I just want to know if your people are in online, please say hi so that I will understand. So that you people are in online. Okay? Yeah. Mm, right. Okay. The today's session is all about summary of IS 800, and we are talking about fifth part. In this fifth part, I will tackle the remaining provisions in beams, and I will tackle the other provisions which are there in plate gutter also. These are two things I will tackle for today's session. Is that okay, brothers? Right. Okay. Hi, Vasan Sai. Hi, sir. Hi, Vasan Sai. Hope you are fine and everything is working well, right? And before I start the session, I just want to convey a big hi to all of my brothers and sisters who are on the online, right? How are you guys? Hope you are fine, right? Okay. I can recommend you guys if you are a serious aspirant of GATE or ESE or any other competitive examination. I can definitely recommend you, like, so much of free content is already happening in this Unacademy learning app. So I can recommend you to install this Unacademy learning app and use at least the free content. Okay. And if you want to follow me in Unacademy learning app, you can use this link which is given below. If you are able to use this link which is given below, directly you guys will be redirected to my page and you can follow me. When you are able to follow me in Unacademy learning app, the three advantages are there. First advantage is already the free content that I have done in Unacademy learning app, you are able to access that one. The free classes that are going to be held by me in Unacademy learning app, you will be notified about that. And the third advantage is at the end of each and every free class or special class, we will provide a PDF notes that also you are going to get for free of course. These are the three advantages when you had installed this Unacademy learning app and if you follow me, right? Yes. And some people had a doubt like, sir, is there any paid courses happening in this Unacademy learning app? Yes, there are paid courses are also there in Unacademy learning app. You select the goal, whatever you want to achieve as GATE and ESE. After you select your goal as GATE and ESE, and in the main tab, in this way, in the main tab, you go and select plus courses or classes. When you select this plus courses or classes, you are able to see a tab called get subscription. That means this get subscription is you are going to get subscribed to the paid course. After when you press get subscription, you will be given with two different types of paid courses. One is plus course and another one is iconic course. In plus course, the advantages are four, like the first and foremost advantage is instant doubt resolution. And second advantage in plus course is let us suppose you will be supported with the support of test series. That is the second advantage, so that you will understand at what level you people are in terms of performance, and you can increase or and you can improve your performance definitely. And third advantage is all the courses provided by Unacademy are structured courses. There is no need to plan yourself. We will provide the entire plan. With the help of that plan, you are able to crack each and every. That is the third advantage. Fourth advantage is unlimited access will be given to you guys in the form of recorded version if you are not able to come down to live. These are the four advantages. All these four advantages will make you ready to crack any sort of competitive examination with very pretty good rank. There is no doubt. In Iconic, there are two other advantages are there, brother. The advantages in Iconic are you will be provided separate notes when you had taken the Iconic course as provided by Unacademy. That is fifth one. And sixth one is you will be provided with a special mentor who will track your performance, and he will resolve all your doubts regarding your subject also, and he is able to track your performance, and he will send to the performance reports also. That is the sixth advantage. So all these advantages will make you to crack any sort of competitive examination with pretty good rank. There is no doubt at all. But I just want to convey, if you want to take plus codes or iconic codes to get 10% discount, brother, to get 10% discount, it will ask you like, is there any referral code is there? If you are able to apply this referral code VD10 directly, 10% discount will directly come to you on all the courses in Unacademy platform, in Unacademy Plus. Okay, so don't forget to use this code VD10 either for plus codes or iconic codes, brother. If you use this code, definitely 10% discount will come. Some people will say, sir, this is my first class, please introduce yourself, because we are new to this platform. Okay, let me introduce myself. I am Venkata Tilak. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also, which is PhD. My background of education is completely into structural engineering. So here also in an academy, I am going to teach only the structural subjects ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. These six subjects only I am going to tackle. Right. Coming to this university has produced six Nobel Prize winners, brother. So producing six Nobel Prize winners is not a joke. You can understand that one. And coming to this university, ranking is always far better than IITs and IIC Bangalore. I don't have any partiality, brother. It is not told by me. It was advocated, it was supported, it was informed by almost all the ranking agencies globally. I am not, I don't have any partiality. If you want, you can Google it, you can search anywhere. Maybe by Times higher ranking or any global ranking. Okay. This university ranking is far better than IITs and IIC Bangalore from the past 100 years. And some people will also ask us, sir, what is your previous work experience other than teaching? Previously, I worked as research scientist or research engineer in University of South Carolina. This is in USA. For the same, for that research project, I worked as a team leader also. Team lead. And in addition to this one, previously I worked as head of the Department of Civil Engineering in STEM College. This is in Andhra Pradesh. This is in India. Whereas this USA is in USA. That means I have both local experience and global experience. Being a structural engineer, even till today also I am working as an independent structural design consultant. I personally give structural drawings to my clients. I personally give material testing reports to my clients. These are the two things I provide to my clients, brother. And coming to my teaching experience, totally I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. I had mentored more than lakhs of students till now. Right. This is my brief experience. This is my about my brief experience, brother. So yes. Some people will also ask us, sir, is there any, sir, you asked us to install this Unacademy Learning app. Now, how to install the Unacademy Learning app? So go to Play Store and type this name Unacademy Learning app. You are able to see a screen with this championship type of trophy symbol. You install that app. After you install that app, you are able to see a screen on the right hand side in this way. In this screen, in this screen, you right now you had installed the Unacademy Learning app. After you install the Unacademy Learning app, this is the target what you want to achieve. You can keep that as GATE and ESE, or maybe other state PSU examinations. If you want to crack, you can keep that as the target. Okay. And this is how you can select the target. Some people will also ask us, sir, can you tell me again how we can follow you? So if you want to follow me, I mean the second question is how you can follow me. So the thing is, in this main tab, go to free courses. After you go to free courses, and in the search button you type my name completely, Venkata Tilak Uppalapati. When you type my name Venkata Tilak Kuppalapati, directly my profile is visible to you. When my profile is directly visible to you, you just follow me, right? I can say you just follow me. When you are able to follow me, I can say like, you know, the advantages in following that I already teach you, that I already told you, right? Some people will come and ask us, sir, okay, this is one way that we can follow you by using this link, or this is another way that we can follow, this is the second way, but both are one and same. Okay, fine. Some people will also ask us, sir, how we can take the paid course, can you explain again please? Yes. So if you want to take the paid course, here after you select this target as, select the goal as GATE and ESE, in the main tab go to plus, this is the main tab. In the main tab go to plus courses. After you move to plus courses, you can see here in the screen, you can see the terminology called as tab called get subscription. When you take the subscription, you will be taught with India's topmost faculty directly, and the courses will be taught separately in English and also separately in Hindi, right? When you had taken subscription, you will provide access to all the courses that are provided by Unacademy. When you press this get subscription, there are two courses are there. One is plus course and another one is iconic. Any course you can select, any of the paid course you can select. But before you pay for these courses, if you want to get 10% discount for any of the courses, you should use 10%, you should use this code, referral code VT10, directly 10% discount will come. After you select plus codes or iconic codes, you people will be redirected to the payment page. At the payment, you can make the payment, all the payment at a time you can pay, or you can pay by installment, that is your choice. So depending on your comfort, you do the payment by credit card or debit card in terms of installments or in terms of single payment. It's up to you. Okay, then you got the subscription. Then the topmost educators of India are right now available at your doorstep through Unacademy by using the single code VT10. Okay, right. These are the advantages when you had taken the paid course, brother. Daily live classes, resolution of instant doubt resolution is possible, and test series support is possible. And you there is no need to plan yourself. We will provide the entire plan. If you follow the plan, you are going to get very good success. There is no doubt. That is the third advantage. And the fourth advantage is you will be provided unlimited access to the recorded form of lecture if you are not able to, if you are not available to come down to live. For n number of times you are able to access the same lecture. These are the four advantages which will make you ready to crack any sort of competitive examination, brother. And I can say these are some of the topmost educators that we have directly in Unacademy Learning App, and the classes will be taught separately in English and also in Hindi. So there won't be any language barrier also, brother. Those guys who are comfortable with English, they can go to English classes. Those guys who are comfortable with Hindi, those people can go to Hindi classes. Right. So some people will also ask us, sir, till now in GATE and ESE, till now we people had launched 8 courses. Out of those 8 courses, few courses are in English, few courses are in Hindi. Few courses are long-term batches, few courses are short-term batches. When you had taken this paid course, brother, you will be provided access to all the types of courses that are provided by Unacademy in your particular stream, which is in civil engineering. Right. Coming to the financial terms, let us suppose if you are a final year student, if you want to purchase 12 months subscription, in such case the cost after 10% discount is 27,225 after 10% discount. Whereas if you are a student of third year or second year, I can recommend you guys with this 24 months course, which is costing around 39,600 after 10% discount. Okay, right. So for any of the course from 1 month subscription to 24 month subscription, you should use this code BT10 to get 10% discount, brother. Right. So I just want to convey, every day my class is happening in this Let's Crack GATE and ESE Civil YouTube channel. Every day my class is happening by 11 a.m. So you can inform the same thing to your friends so that they will also get benefited one thing. And I just want to convey one more thing. I can also recommend you guys, Kamalakar Pandey sir class is happening every day by 9 a.m. You can take help of Kamalakar sir Pandey's class also for non-structural subjects, brother. I can recommend even Kamalakar sir Pandey's class also for you. Okay. So before I start the session, I just want to convey you like please subscribe to our Let's Crack Gate and ESE Civil YouTube channel so that you will get most of the free content that is happening in this YouTube channel, and don't forget to press the bell icon. If you press the bell icon, the notifications will directly come to you, brother. So please subscribe to our channel, and please raise a thumbs up so that you will get more free content in this way, so that you are able to encourage, and please inform the same thing to your friends. Please share this video, like this video, and subscribe to this channel, so that we can do more videos for you, right? Definitely. And for you guys, I already started a Telegram group, and the name of the Telegram group is Unacademy underscore Civil Engineer Tilak. If you want to come down to this channel, you can use the link which is directly given below. Use this link which is directly given below. If you are able to press down this link directly, you will be able to come down to my Telegram group, right? And you can post your doubts there. I will take care of your doubts. Okay, right? Shall we start the session, bros? Vasant Sai or any other person who are on the online, shall we start the session? So can you see this question? The area AP of cover plates in one flange of a built-up beam is given by. So if you see, if I take a built-up beam, brother, if I take a built-up beam in this way, if I take a built-up beam, this built-up beam, this is a normal rolled section. Over this rolled section, if I had gone for some plates, flange plates in this way, right? Right. In such case, the area of cover plates of one flange, if AP is the area of the cover plates, this is AP that they are giving. AP is the area of the cover plates of one flange of a built-up beam. Then how we can work out that area of the cover plate required? So what is the area of the cover plate required? How we can say? Let us suppose the section modulus required is this jet required is the section modulus required to resist the bending moment of MU. What is the moment that is? What is the moment of resist? What is the section modulus that is provided by by the rolled beam? So section modulus of rolled beam, I can say of rolled beam. If I remove this section modulus required from this section modulus provided by rolled beam, that is equal to the section modulus that is required by I can say cover plates, isn't it or not? Cover plates. How we can write about the section modulus of cover plates, brother? This is the section modulus. How we can write about the section modulus? Section modulus units are millimeter cube. How we can work out the section modulus? It is the first moment of area with respect to the neutral axis. I want to work out the first moment of area with respect to this neutral axis. What is the first moment of area of this cover plates with respect to this neutral axis? First moment of area AP into this distance is almost, I can say, h by 2. This distance is almost h by 2. So how I can write this ZP required by cover plates? First moment of area with respect to neutral axis for these two plates, I can directly write AP into h by 2 plus AP into h by 2. So directly I can write this as, from this equation, AP area of the flange plates provided by one cover plate into h, it is equal to Z required to resist a bending moment of designed bending moment of MU minus Z, that is section modulus of the rolled I section, I can say, maybe rolled beam. This is what I can say. So from this one, how I can work out the area of the single cover plate? Area of the single cover plate is equal to ZP required minus ZP of rolled beam divided by H. They didn't give the terminology called as rolled, but they had given jet for a beam section, which is the rolled beam, if you think. So directly the option for this one is, what will be the option, brother? Directly the option for this one is directly D for Detroit. Is that okay? Vasan Sai, is that okay? Right? So shall I move to the next slide or next question? Is that okay? Right? Moving to the next question. Right. Right. So can you see this? By how much percentage is the permissible stresses in grillage beam be increased if it is encased in concrete? So if the grillage beam is encased in concrete, its permissible stresses can be increased because the grillage beam is encased means it is laterally supported also, or in other way the grillage beam is encased means I can say definitely the grillage beam will have lateral confinement. Grillage beam is having lateral confinement. When the grillage beam is having lateral confinement, definitely it is able to resist more load. It is able to resist more load. So in such case, as per IS 800, the permissible stresses can be increased by some percentage. Permissible stresses can be increased by 33 percentage directly. So in this case, as per IS 800. So I can say directly option C will be the correct option. So moving to the next question, brother. Shall I move to the next question, brother? Okay. So I hope you are able to see the next question. In this question, in a simply supported beam of span L, a simple supported beam is there. Okay. A simple supported beam of span L is there. Okay. Each end is restrained against torsion. So this end is restrained against torsion. So this end is restrained against torsion. Okay, that is here it won't allow indirectly it is restrained against torsion. Compression flange is being unrestrained. The compression flange is not able to get restrained, so the compression flange is not embedded inside the slab. So compression flange is being unrestrained means compression flange is not restrained. In other words, physically I can say compression flange is not kept inside the slab. That is one way. And compression flange is not supported by the slab by using shear connector. Compression flange is not compression flange is not what I can say. Compression flange is not supported by beam or supported or restrained by beam using shear connectors. That is the meaning. So these are two are not happening. So it is able to make the deflection very easily. That's what it meaning. Okay. So according to IS 800, the effective length of compression flange. What is the effective length of compression flange? Compression flange is not restrained between. It is only restrained at this end and at this end. Between these two ends, the compression flange is not at all restrained. Then in such case, the effective length of this compression flange. Here it allows rotation. Here it also allows rotation. This is the zero bending moment and this is the zero bending moment. So directly you can think like so effective length. So maybe if you take the effective length in case of simple supported beam where only ends are restrained by torsion, but compression flange is not restrained at anywhere. In such case, effective length is 1 times of L. So directly I can keep the option is only option A. Is that okay, brothers? Right? Because it is simple supported. This is SS. This is also SS, simple support, right? Can I move to the next question, bros? Vasan Sai, Suman Saha. Hello, hi Suman Saha. How are you? Hope you are fine. Right. Hi Sumit Saha. How are you? After a long time ago, I am able to see you. Right? Hope you are fine. Okay. Shall I move to the next question? Right? Yeah. Moving to the next question. How are you, brother? Okay. I hope you are able to see in web crippling the bearing length. What is the length of bearing under the reaction at the support? What is the bearing length under the reaction at the support? So if you see the options are directly there with respect to working stress method. So I hope if I take, this is a beam. So when this is a beam, this beam is directly resting on, this beam is resting on a support of width B, right? A support of width B. So they are expecting like what is the width of this web crippling as per old code of practice, because the options are matching with old code of practice. So what is this web crippling means? Web crippling means it is a web bearing failure. In case as per IS 800 1984 code, old code of practice, at what angle the load dispersion will takes place at the level of this web crippling failure. The load transmission will takes place from the reaction support at an angle of 1 vertical to 3 horizontal, root 3 horizontal. If I take in this way, generally if you take an I section, this web crippling failure will happen exactly at the level of root radius. So if this is the level of root radius, if the depth of the if the depth of this critical section from the bottom is h stands for the depth of the root of the fillet, including thickness of flange, in millimeter that was given. Then I want to take, this is the effective bearing width for web crippling. So this is the effective bearing width. How you can work out? This is h. So what will be this answer, brother? So for one vertical, the horizontal is root 3. For h vertical, the horizontal is root 3h definitely. So here in this case, as this support is at the end, the load dispersion, clearly the load dispersion can happen only on one side. The load dispersion cannot happen on the other side, which is 8. In 8 the load dispersion cannot happen. So directly I can say this is the effective width for web crippling. Which, how we can write this effective width for a web crippling? The width of the bearing plate, the effective width of the bearing plate is B, plus this is root 3 times of h. So I can write root 3 times of h. This is the answer for effective width of web crippling as per old code of practice. Please understand the difference. There are two codes are there. This is as per working stress method. This answer is as per old code of practice IS 800 2000, sorry, not 2000, sir, 1984 code. Now some people will say like, sir, what is the answer for the same question? So the as the options are given directly as per old code of practice na? So I can write B plus root 3 times of h directly. I can say the option is B. Now this is as per working stress method. Especially Suman Saha or Sumit Saha will ask us, sir, okay, fine, now can you tell me the answer for the same problem when the method is as per limit state method, sir? Okay, when the method is as per limit state method, in such case what the code says, brother? The code says like you take the load dispersion from this support at an angle of if you take load dispersion from the support at an angle of 1 vertical to 2.5 horizontal. This is clearly I'm saying 1 vertical to 2.5 horizontal. When it is 1 vertical to 2.5 horizontal, right? So in this case, now you people tell me, this is the level where that root of fillet is existing. I hope you know this is the level where root of fillet is existing at this level, na. So at this level already, what is this? This thickness is h. The h is the depth of the root of fillet, including the thickness of the flange. So if this is h, in such case, directly we can write this horizontal. This is the effective flange width, na. So this is 2.5 times of h. This is already b. So directly the load dispersion angle will get changed from the support. That is the difference in clauses as per working stress method and as per limit state method. So as per limit state method, the answer is b plus 2.5 times of h, which is thickness of the flange plus root radius. We are talking that thickness of the flange plus root radius as directly h, na. So we can take this is the answer as per limit state method. Directly we can write. So as the given options are directly as per working stress method, you can pick the option as B. Is that okay, brother? Any other? So can I move to the next slide, bros? Is that okay? Right. Moving to the next question. Right. So can you see here? So we had moved to the plate girders. Now can you see this question? Economical depth of plate girder. So what do you mean by economical depth of the plate girder? If you provide that depth of the plate girder, economical depth of the plate girder, then the cross sectional area of the cross sectional area of the girder will be less. So obviously it will result in least weight. So economic depth of the girder is to get minimum self weight of girder or minimum cross sectional area of girder. To get minimum cross sectional area of girder, we generally go for this economic depth of plate girder. Now there are again two things, the formulas as per working stress method. So here also the formula as per working stress method is different, as per this limit state method is different. Okay, so if you see this working stress method, as per working stress method, that is as per IS 800 1984 code, the economical depth of the plate girder, maybe I can say over economical depth is D economic. I can directly write it as it is 1.1 times of square root of m by the permissible stress, permissible bending stress in tension. What is that permissible bending stress in tension, brother? Permissible bending stress in tension is given by the terminology called as sigma TW. So I can write sigma TW, sigma TW into thickness of the web. I can write TW, where TW is the thickness of the web. This is how we can work out the economical depth of the plate girder as per working stress method, right? So now coming to this limit state method, the limit state method, I hope you know the economical depth. I had already derived this before 2 months, especially by the time of plate girder. I had derived this one also, which is cubed root of m by k into fy. So K stands for the value of d by Tw. So what is the value of d by Tw? D by Tw is depth of the web by thickness of the web indirectly. The value of d by Tw, whatever may be the value of depth of the web by thickness of the web, you fix for that corresponding to the depth of the web by thickness of the web. This is the economical depth that you need to provide, where everybody will also ask us what is this. M stands for, M stands for maximum bending moment to be resisted by the plate girder, to be resisted by the plate girder. How we can work out this maximum bending moment? We can work out the maximum bending moment by using the concepts of structural analysis, or by using the concepts of, I can say, strength of materials, anything I can say, using concepts of SA or SM. That's what I can say, brother. So I hope you know m, and the value of k can be fixed. The value of k shall be when there is no stiffness are required. The k value can be fixed as one value. So if I want to mention the k, we can be, I can say fixed, and this is also known, fi is also known. So like that you can work out. Some people will say allowable bending stress. How we can work out the allowable bending stress? As per old code of practice, it is 0.66 times of fi. Even this is known, m is known, tw is known. So directly we are able to work out economical depth. This is economical depth as per working stress method. This is economical depth as per limit state method. So if you see the options are there only with respect to working stress method. So directly you can pick option B for Boston is the correct option, as the options are only matching with respect to working stress method. Limit state method, the answer is different, right? Right. For either this economical depth, for this depth, this, try to write the equation for moment of resistance, and partial differentiation of that equation of moment of resistance with respect to area of the flange is equated to 0, because the area of the flanges should be less. Like that we will try to derive, and you will end up with this as economical depth as cubed root of m into k by fi, right? So shall I move to the next question, brothers? Right? So can I move to the next question? So moving to the next question, right? I hope you are able to see the next question, brothers. So consider the following statements in respect of design of uh, web and flange splices. So what are the statements for this web splices and flange splices? I can say flange splices and web splices. So I just want to say one thing: flange splices should not be done at maximum bending moment points. If you done at maximum bending moment points, then the cost of connection will be more, because flange splicing, if you take any sort of beams with flanged sections, flanges resist bending moment. This web will resist shear forces, right? Web resist shear forces. Flanges resist bending moment. From where you got this conclusion? From strength of materials. If you refer, that is the basic conclusion. So what is splicing? Splicing means nothing but joining. Let me write splicing. Joining. Why I need to join the flange plates? Generally, if you see, the flange plates are web plates that are directly available in market. The length of the flange plates or the length of the web plates that are available by Indian rolled mills are at max 6.5 meters. But if you take the plate gutter, the length of the plate gutter may be 20 meters, 30 meters, or anything, right? In such case, one flange plate must and should be joined adjacently. So that means joining of flange plates is required, and joining of web plates is also required to get a desired length of 20 meters or 30 meters, whatever that may be. So the joining is a mandatory. Now the question is where I should join, where I should not join this flange splicing, where I should join, where I should not join this web splicing. Yes, I hope you know flange splices should not be done at maximum bending moments. If you do at maximum bending moments, the cost of the connection, rivets, and all these things will be get increased. So common sense says like flange splices should not be done at maximum bending moment points. That is, what about web splicing, brother? Yes, Suman Saha, yeah. So where this web splicing cannot be done. So I hope you know web will resist shear. Where the shear is maximum possible. So this web splicing should not be done at the maximum shear force point, right? So should not be done at maximum shear force points. Generally, what are the examples for maximum shear force point? Means it supports. Now, generally it supports. Maximum shear force generally exists. So based on this stuff, directly what is the answer? Directly you can see. So can you say like flange splices shall be designed for actual bending moment at the section? Yes, flange splices are flange plates resist bending moment. Na? So the flange splices, that joining, that connection shall be designed for actual bending moment at the section. This is perfectly correct. There is no doubt at all. Right? Flanges resist bending moment. Right? So can you see this one? Flange splice shall be designed to resist the actual shear at a section. Dear, I already mentioned shear is taken care by the web. So the web splices, or the web will take care of the shear. So flange splice doesn't have any rule about that one. So this is wrong. This option number 2 is wrong. As well as the shear is taken care by the web, so the shear is taken care by web splicing or web. So it depends. So if you take the third option, web splicing shall be designed to resist the actual shear at a section. Yes, the shear at a section is, if you take at a section if the shear force is V at a particular section, if you want to go for web splicing, the splicer, that connection of that web must and should be designed to resist that shear force. Definitely, why not? That is 100% correct, because the web resists shear. There is no doubt at all. So option number 3 and option number 1 till now are correct. Coming to the fourth option, brother. Web splice shall be designed for actual bending moment. No, brother. Web splice will resist only shear force. It is not going to take any sort of bending moment. So I can say this fourth option is also wrong. So I can say first option and third option are correct. So what are first option and third option are correct means I can say option A itself is the correct na. So directly can I say option A? Is that okay, bro? Suman Saha or any other person who are on the online, can I move to, is that clear? Can I move to the next question? Right? So moving to the next question, brother. Right. I hope you are able to see this question. Consider the following statements. I am taking the following statements. So horizontal stiffener is provided. When the horizontal stiffener is provided, when we require that horizontal stiffener to be provided, brother, the horizontal stiffener to be provided is, I just want to convey the reasons before I just tackle this one. So one thing, so when horizontal stiffeners are required, when horizontal stiffeners are provided, I can say if you had designed vertical stiffeners, if the design of the vertical stiffeners are becoming very close, in such case the next level of providing the stiffeners is horizontal stiffeners. Na? So when I provide the vertical stiffeners, when the design of the vertical stiffeners are coming too close, in such case I need to provide the horizontal stiffeners. That is first one. So maybe can say when vertical stiffeners are becoming too close. Second one, when I can say like when d by tw, depth of the web by thickness of the web, is more than 200, in such case I should start using this horizontal stiffener, right? Start using the horizontal stiffener when depth of the web by thickness of the web is more than 200, or in other words, when I use thin web plates, are, if only thin web plates are available, when I use, or if available web plates are very thin, in such case I need to provide this horizontal stiffener. This horizontal stiffener, what this horizontal stiffener will resist? This horizontal stiffener will resist the longitudinal buckling, compression buckling of flanges, compression buckling of web, not flange, the web. So in order to stop the longitudinal compression buckling of web, I need to provide, if it is even failing after providing this vertical stiffness. Then the next one is by providing this longitudinal or horizontal stiffness is the mandatory. Now if you check these options, so can you see the tendency of web buckling is less? So the tendency of web buckling is less, then we provide no. When the tendency of web buckling is less, then there is we won't provide any sort of stiffener also, right? Vertical stiffeners are becoming too close. Yes, this is correct. Only thin plates are available for web. Yes, when only thin web plates are available as web. So in such case, the depth of the web is small. In the when the depth of the web is small, we will provide this horizontal stiffener. No, no such thing is there. So directly I can say option 3 and 4 are matching. So when option 3 and 4 are matching, so directly I can say like option B itself is the correct one. Is that okay, Sumit? Is that okay, brothers? Right? Is that okay, brothers? Is that okay? Shall I move to the next slide? I mean, next question, right? So, yeah. So, vertical, so Vinith Shukla. Okay. 1 second. Yes. One second. Very good question, brother. Let me write that for you. I mean, let me say that to you. So, some people say, sir, when vertical, sorry. Some people say like, sir, vertical stiffeners are, you are saying when vertical stiffeners are too close. What is the meaning of this too close? The spacing, I can say if the spacing of vertical stiffeners are less than or equal to d by 3, depth of the web by less than or equal to 3. In such case, the vertical stiffeners are very close to each other like this. So when the vertical stiffeners are becoming very close, in such case, I can say doing the connection between that vertical stiffener and the associated web is very difficult. In order to make that connection very usual, we generally should not keep spacing not less than d by 3, not less than d by 3. When spacing of stiffeners are less than or equal to d by 3, in such case, making connection between vertical stiffener and web is very difficult because the spacing is very congested. In that very congested spacing, can you do that connection very well? It is difficult, right? Yes. Vinith Shukla, I am trying to teach the third point only. I am trying to teach the third point only. Please allow me some time while I am teaching something. Please listen. Okay, I am teaching. So I hope you can say when this is the spacing, brother. This is the spacing of stiffeners. Let us suppose you had provided the spacing is less than or equal to d by 3, depth of the web by 3. In such case, it is difficult for you to make the connection between the vertical stiffener and the web. So it is very difficult for you to make the connection within that very small gap, right? So that's the reason why the code says like you restrain at the minimum spacing that is required for vertical stiffener is d by 3. So d by 3 is the minimum spacing that is required for vertical. It should be more than or equal to d by 3. But if you when you try to keep the spacing less than d by 3 in to avoid this buckling, by that time you cannot make the connection properly. So in such case, you should keep the spacing as more than or equal to d by 3, and to avoid that shear buckling of the web or anything, I should go for horizontal stiffener also. Is that okay? Right. Is that okay, brother? That's how the code has prescribed to make our lives very easy. Okay. Right. So can I move to the next slide, brother? Some people had a question like, sir, you say like some minimum spacing for vertical stiffeners is d by 3. So I just want to convey here itself. Can I erase the screen? So 1 second. Let me write here. Minimum spacing for vertical stiffeners is equal to d by 3. What is the maximum spacing for vertical stiffeners? If you keep the spacing more than this one, then the vertical stiffeners will not able to stop the shear buckling. So which is 1.5 times of D. So by the time of design, please keep the spacing in between D by 3 and 1.5 times of D, brother. So that is also a clause that is advocated by IS 800. Okay, IS 800 guidelines. Right? Can I move to the next question, dear Vinit Shukla, brother? Or Suman Saha, Vasan Sai, or all the brothers who are or sisters who are on the online. Can I move to the next question? Is it okay? Moving to the next question, brother. Right? Right. So I think this is a question which is completely based on this. I need to teach about the bridges class. If you refer to IRC 6, this question is based on Indian Road Congress 6 about loads and stresses. About loads and stresses. This question is not in the syllabus, but anyway, this type of question was asked once in IES. I had taken this one, but this question IRC 6 is not in syllabus, which is how to consider the loads and stresses in cases of bridge structures. Loads and stresses in bridges, right? In a steel bridge, I can say in steel bridge of span less than 9 meter for class A loading for wheeled vehicles, I can say not in portion. The impact factor, as the bridge is having the loads applied are moving loads, and the loads are moving loads. So moving loads, so when I apply a static analysis, for that static analysis bending moment and shear force, I need to increase this bending moment and shear force with the help of a factor called as impact factor, because the loads are keep on moving. And if I consider that loads which are keep on moving for spans less than 9 meter, the option is 25%. This, if you want to refer this one, you go and refer loads and stresses in bridges, which is the code of practice number is IRC 6. If you go and refer, yeah, let me that one time that question was asked, so that's the reason why I am just going for that one. Else I am not interested to teach that one, because if you refer, sometimes that question will might also be appear to you. That's the reason why I had worked out that one. Okay, right. So coming to this question number 144, the horizontal stiffeners are needed in plate girder when we need to provide the horizontal stiffeners. When we need to provide the horizontal stiffener, brother, the see horizontal stiffener is provided when D by TW is more than or equal to 200, right? Or in other words, TW should be less than, even TW is less than D by 200. This is the thing when I can say the horizontal stiffener is required. Horizontal stiffener is required when thickness of the web is less than d by 200. Yes, when it is less than d by 200, then we require that one. So say I can say option B itself is correct. Is that okay? So directly I had mentioned this is from serviceability requirements. Directly we can say. Is that okay? It is not C, brother, right? So the option for here for this B, brother. So this is what we can say. Some people had a doubt like, sir, when I can go for this vertical stiffener, can I discuss all this stuff here? So when I say no stiffener is required, when I say no stiffener is required, in such case T by TW should be less than or equal to 85 as per old code of practice. When D by TW is more than 85, I can say no stiffener. No stiffener is required. When d by tw is more than 85 and less than or equal to 200, in such case vertical stiffeners are required. The 200 or 250, dear, 200 only. Dear, 250 is the terminology, dear. Beyond 200, see, I hope I had already mentioned to you in your previous stuff, like, okay, 200 only, brother. It is not 250. Let me write. Let me write everything clearly here. Okay. So when it is there, it is vertical stiffeners are required. When D by TW is more than 200 and mm, less than or equal to 250, I can say vertical stiffener plus 1 horizontal stiffener. What is the benefit of lapping on the web on a multiple spliced connection? 141. 141. Let me check. Yeah, structurally. What is the benefit of lapping? I didn't talk about lapping, brother. Na? So maybe you are talking about 141 question. Dear, you are talking about the lapping is different, splicing is different. Lapping is you are keeping one plate over the another plate. That is nothing but lapping. Splicing means nothing but joining, brother. Dear Sumit Saha, Dear Sumit Saha, I already mentioned what is splicing joining. Why you are joining the flange plates and why you are joining the web plates. Let us suppose if this is a flange plate, brother. I want a plate girder of length like 20 meters. But the Indian mills at max will provide. Please listen. Please listen. Please listen. Please listen. Sumit, Vinit, please listen. So the maximum length of the plates that are provided by I can say the maximum length that are provided by Indian mills are 6.5 meter only. If you want to go for 20 meters, then you need to join. This is the flange plate. Another flange plate should be joined. The another flange plate should not be kept over this one. The another flange plate should be kept very near, very side to this one. And after I kept another flange plate and another flange plate, I am joining these flange plates. How I can join these flange plates, brother? I can join these flange plates by going for two cover plates here, maybe clearly two cover plates here, and then I can go for the bolting or riveting with the help of HSFG bolts. This is how we will go for bolting. I am not lapping this one, man. Lapping is making one plate to be kept over the another plate is nothing but lapping. It is splicing, brother. Okay. Let's say web plate. Okay. Let's say so. Okay. Even web plate also. Dear, you tell me even web plate. What is the length of the web plate that is available in market, brother? The length of the web plate that is available in market or flange plate or web plate. The length of the flange plate or web plate that is available for Indian rolled mills is at max 6.5. Beyond 6.5 you cannot get anywhere. The length like 20 meters, 30 meters length of the flange plate and web plates are not possible by using Indian mills. So in such case, if you want to get 20-meter length, yes, it is limited. Dear Suman Saha, yeah. You can join it. Joining is nothing but splicing, because the length of the flange plates and web plates that are directly available in Indian rolled mills are less. At max, it is limited to 6.5 meter. If I want to get 20-meter length of the plate cutter, then definitely I need to join flange plates, and definitely I need to connect web plates also. Okay, dear Sumit Saha. Right. So if it is a web plate, maybe I can show you like this is a web plate. This is a web plate. These two web plates are kept side by side with the help of small plates. In this way, we can go for connection. Maybe here in this way with the help of welds or bolts, or maybe with the help of rivets, we can go for joining. So here by the time of joining, this is one web plate and this is another web plate. I am not keeping one web over the another. I am keeping two webs side by side. With the help of a plates, I am going for bolting or riveting or welding. This is how we are going. We can join it. Okay. So please one thing I can ask you, like, so if you had a doubt in a particular question, by the time you please ask after 4 questions or maybe after 5 questions, if you are asking that question, that means you are wasting your time and my time also. Okay, please be aware of that. Okay, yeah, right. So maybe I'm coming to this one. So when I came down to when depth of the web by thickness of the web is more than 200 and less than or equal to 250. In such case, in addition to vertical stiffener, one horizontal stiffener is provided. is required, where you will keep that one horizontal stiffener. That one horizontal stiffener is provided at a depth of zero point 0.2 times of D from top compression flange. From top compression flange. Some people had a doubt like why we are keeping that horizontal stiffener in the compression web only. Why can't it be kept in tension web? So because of the buckling is possible, the horizontal buckling is possible in compression web. To stop that horizontal buckling in compression web, this a longitudinal stiffener shall also be kept in compression zone. So that's the reason why the code says if you are keeping the first horizontal stiffener, that first horizontal stiffener must and should be kept at a depth of zero point 0.2 times of D from the top compression flange. Okay, right. And some people will say, sir, if I want to go for second web, when D by TW is more than 250 and less than or equal to 400, in such case I can go for vertical stiffener plus, instead of one horizontal stiffener, I can go for second horizontal stiffener also. The second horizontal stiffener should be kept at the level of neutral axis. Second horizontal stiffener will be kept at the level of neutral axis. Is that okay? Suman Saha, can I move to the next slide? So this is as per old code, right? So coming to the new code of practice. So shall I say the same thing as per new code of practice, brother? Yes, coming to the new code of practice, these limits are different. So new code I can write. For new code, they are saying D by DW, no stiffness is required when it is less than or equal to 67. No stiffener as per limit state method. When D by TW is more than 67 and less than or equal to 200, the remaining things are same. Vertical stiffener. D by TW is more than 200 and less than or equal to 250. Then in addition to vertical stiffener plus one horizontal stiffener. When D by TW is more than 250 and less than or equal to 400, vertical stiffener designs plus two horizontal stiffeners. The second horizontal stiffener should be kept at a level of neutral axis. This is how we need to use, right? Hi Reshu Singh, how are you? Hope you are fine, right? Right. Yes. Timing क्या है sir class? I am new here. Dear, every day my class is happening by 11 a.m. brother. 11 a.m. in this. Please subscribe to this channel. Okay. So every day my class is happening by 11 a.m. Is that okay? Reshu Singh. So brothers, can I move to the next question? Is that okay? Right? Moving to the next question, bros. So I hope you are able to see the next question. Which of the following is correct? I need to pick the correct statement, right? So I mean correct answer. An intermediate vertical stiffener connected to the web is designed to withstand a shearing force. So I hope if I take this is a plate gutter. So what are stiffeners? Stiffeners are some of the elements which are useful to stop web buckling and to stop web buckling and to stop bearing failures in web, right? This type of elements are nothing but stiffeners. If I take this is the plate gutter, for example, generally this is the support. At the support, maximum shear force is there na, so because of which to avoid web shear buckling in web, I generally provide a vertical stiffener here. If I provide a vertical stiffener at the other positions other than at the supports, such stiffeners are nothing but intermediate vertical stiffeners, we call it as intermediate vertical stiffeners, right? Now in this case, for this intermediate stiffeners, if you take generally, if you take maybe this is how the length is, maybe I just want to convey you, this is how the support, Now let us suppose some uniformly distributed load. So can you predict the shear force sketch? Okay, it may be in this way. So now in this case, what is the shear force for which this intermediate stiffness, minimum value of shear force for which the intermediate stiffness must and should be designed? The intermediate stiffness must and should be designed for a shear force which is this is the intermediate stiffener na. So the connection between the intermediate stiffener and this web, I hope you can say this is the web. So the intermediate stiffener and web must and should be designed for a shear force with weld or anything that should be able to take care that should be able to take care a shear force of not less than 125 t square by h, where everybody call what is this t? T stands for thickness of the web. T stands for thickness of the web, we call it as, and h stands for depth of the web. So this is how we can work out. This is this is shear force that we are designing here for this intermediate vertical stiffener and the associated web. That connection should be able to design a shear force of this much value. This is as per old code of practice. That is as per I can say working stress method. The same class. What is the shear force for which the intermediate stiffness must and should be designed for as per new code of practice? I just want to convey as per new code of practice, because we need to compare both na. As per new code of practice, the same clause was given as, which is the intermediate stiffener must and should be able to resist a shear force of thickness of the web square by 5 times of bs. So what is this tw stands for? Tw stands for thickness of web. What is this bs stands for? Bs stands for outstanding leg, outstand of this vertical stiffener, I can say outstand of vertical stiffener. People had a doubt like, sir, we know the thickness of the web, it is okay. What is outstand of this vertical stiffener? How we can say about this outstand of the vertical stiffener? I hope if you see, maybe let me erase this stuff. If I take the eraser, okay. This is in plan, for example, this is the center line. For example, this is the center line. This is the center line of the web. This is the web. On either side of the web here, this is how the vertical stiffness are there. This is what I mean to say is outstand of this vertical stiffener, we call it as bs, and the bs value is less than or equal to 20 times of tq, definitely, right? This is how the stiffener outstand width was already provided, right? What is tq? Tq stands for thickness of the stiffener, right? Right. Right. So is that okay, brother? So this is as per old code of practice, the answer is this much. As per new code of practice, the answer is this much. I mean, let me show with a red color. This is as per new code. New code instance as per limit state method. As this is as per working stress method. Okay. The options are matching only with respect to working stress method. Now, so directly I can keep option D is the correct answer. Is that okay? So can I move to the next question? Is that okay, brother? Guys who are on the online, can I switch to next question? Right? Moving to the next question, bros. So can you see this question? Which of the following is most efficient? Okay, most efficient section for simply supported gantry gutter. If you take a simply supported gantry gutter, I can say this option is not box section. This option maybe I can say yes. Oh, 1 second. Another option is directly I can say as channel section. Out of these four options, which option is so is a very good profile to take the profile for gantry girder? So I hope you know what is gantry girder. Gantry girder is a deep beam, or it's a girder which is useful in case of industrial structures for transport of goods from one end of the room to another end of the room, in both in horizontal, in both in mutually perpendicular directions, in any direction, right? I hope you know the gantry girder profile. So if you take the gantry girder is subjected to biaxial bending. Biaxial bending. In order to resist biaxial bending, which of these four options is very best suitable to take care of this biaxial bending case, right? So symmetrical I section. No, if you take a symmetrical I section only with respect to x-axis or z-axis, more resistant, but it is weak with respect to this y-axis. With respect to y-axis, moment of resistance is less, so I can say weak with more resistant, it is less resistant. So this A cannot be option. Back to back connected channel sections. When these channel sections are connected back to back, right? So the back to back connected channel sections, when these channel sections are in this way, again here the problem is these two channel sections are kept back to back. This is not when these two channels are kept front to front in this way. In such case it is more suitable profile to resist, because away from this CG the area should be thrown away, but when it is back to back the area is very nearer to this y axis, so this cannot also be the best profile I can say. Now can you say this option C? If you take this option C, I section with channel section at the top, I hope, let me take an I section. That too, that I section is a IS inner standard wide beam. Let me take an inner standard wide flanged beam, ISW beam, and here the loads will come laterally here, and to resist that lateral loads I need to increase the moment of resistance with respect to y axis. To increase the moment of resistance with respect to y axis, especially in compression zone, that lateral loads, in this way the loads will come. To resist the lateral loads, especially in compression flange, the compression flange is stiffened by using with the help of a channel section. When the compression flange is stiffened by using with the help of channel section, then it is able to resist both. I mean, about x axis the moment it is major, more resistance, and even with respect to y axis more area is thrown about y axis. Now here, because of this channel section, I can say it is able to resist bending about x and also bending about y. So this profile C is the best profile till now I am saying. Coming to option D is channel section. Since just single channel section is not able to resist both higher bending moment about x and y, with respect to y it is less. What is meant by flange angle? The angle which is connected between the flange and web, that is nothing but flange angle. Maybe I can say this is how this flange angle is. This is the flange angle. Why these flange angles are used, brother? Generally these flange angles are used to make the connection between the flange and web, are used. Buffering. Dear, I don't think so, Vinith Shukla. It is not at all buffering, because if you see this Vinith Shukla, I am able to see my lecture directly here. Okay, I hope you guys are able to see my lecture directly in the mobile phone. I am using the same internet. So from my end, there is no problem of internet here, Vinith Shukla brother. So please check your connection. If there is some buffering, I will let you know. There is no buffering here from my side. Please check your connections in that case. Okay. So dear Vineet bro, so in such case just refresh, just close this session and just open the session. Maybe you may get the thing. Okay. Is there any other guys? I don't feel like I am not getting any sort of buffering issue because I am able to see clearly my lecture directly on live. Okay, so from my end there is no buffering issue because I am using the same internet which is connected by Wi-Fi. Okay, and I am using very good Wi-Fi here. So please check your connections. Okay, right. Suman Saha. Okay. Suman Saha, sir, web plate splicing. Okay, flange plate or web plate splicing benefit with reference to torsional resistance. Dear, splicing is not about just torsional resistance, brother. Dear, please understand, dear Suman Saha. You forget about torsional resistance, this are resistance. Generally, to get a particular length like 20 meters or 30 meters or anything, if you take any flange plate or web plate, the length of the plates that are available in Indian rolled mills or in market to make this built up I section, that is at max it is limited to 6.5 meter. Okay, please understand. Forget about the torsional resistance. To get the torsional resistance and all stuff, we will do that one second. Okay, we will do that one, right? So web plate, so sir, web plate splicing benefit with reference to torsional resistance. Dear, web plate splicing is required anywhere. Whenever the length of the web plate is not sufficient, that splicing, that joining of web is very much required. It is not just for torsional resistance, for everything to take care of shear resistance or anything. Just I need to have that continuity of the material. Now, if there is no material, how you can produce a 20-meter length of the gutter or 30-meter length of the gutter, right? So I hope you are understanding. To achieve that length of the girder of 20 meters or 30 meters, the joining of that flange plates and web plates are required. That web plate splicing is able to resist the shear forces, whereas the flange plate splicing is able to resist the bending moment, right? Right, and in particular shearing stress distribution taking care of adequately in general. Don't go to the question, please. Spliced is built up. Dear, spliced is definitely a built up one. We are not saying like even this plate gutter is a built up one only, not brother. Spliced is built up only. Yes, everybody will say that is no doubt at all. It is spliced is a built up. Even this plate gutter is also a built up section, brother. You to achieve that one, you require that much length. You need to splicing. The splicing is a mandatory here, right? Suman Saha. So let me take this question. In a plate gutter, okay, if I take in a plate gutter, flange angle. What is this flange angle should be? The flange angle is able to provide connection between flange angle is able to provide proper connection between flange plate and web plate. To achieve proper connection between flange plate and web plate along this length, if I want to go for with the help of bolts, right? If I don't want to go with the help of weld, if I want to go with the help of bolts, in such case generally you can see here I can say there are bolts are here, there are bolts are here, there are bolts for here, right? So in this case we can go for this in this way, and you can see in plate gutter flange angle should be, you are taking this flange angle, the flange angle should be equal angle or unequal angle. So I can say in case of plate gutter flange angle should be of unequal angle. Unequal angle is preferred. Why unequal angle? Because most of the connection we are doing between the flange and the flange angle, most of the connections, as most of the connection with the help of bolts or rivets we are connecting between these two, higher angle side is required for this connected angle which is connected to the flange. Here this should be the higher side, whereas this should be lesser leg, right? This can be the lesser leg, this can be the higher leg. So I can say unequal angle is the best one. Why I am unequal angle meant? I can say to increase the moment of inertia of the moment of inertia of the section. To increase the moment of inertia of the section, let us suppose this is with respect, this is in front view, this is in plan. So with respect to this plan, if I had gone for this is outstanding leg. This is how the flange is there, right? If the flange side is more on this direction when compared to the side that is attached to the web, this dimension is more. When this dimension is more about this axis, the moment of inertia of this cross section will is getting higher and higher, right? So to increase the moment of inertia of this section, that is one issue, because of which we need to go for unequal angle with higher leg attached to the flange, right? With long leg is in horizontal direction. This is the long leg. So this is long leg. This long leg is in the horizontal direction. So unequal angle with long leg in horizontal direction. What is the second one? So I can say, as the long leg is available in horizontal direction, even for connection also, I am able to accommodate more number of bolts or more number of rivets, right? A large length is available, a large leg length is available for making the connection with the flange plates, with the flange plate. So that's the reason why we should go for especially the connection between the flange and web. If I want to connect these two, I should go for a flange angle which is unequal flange angle with a long leg horizontal. That is the preferable section rather than equal angle, because more connection is possible between the flange and this flange angle, right? Yes. So can I move to the next question, brother? Dear Sumat sir, help me, brother. Okay, sir. What you are saying, sir? Web plate splicing is benefit with reference to. Dear, you please understand. Web plate splicing is required to increase the length of the member, brother. Okay, and in particular, shear stress distribution taken care of adequately in general. Okay, don't go to the question, please. Spliced is built up. Yes, spliced is built up. What is your question, brother? Dear, web splice plate is required. Splicing of web is required, and splicing of flange is also required, brother. What is your actual question? Please tell me your actual intention. What is your actual intention behind? Suman Saha, please type the question in neatly so that I will understand the question. See, the splicing is required. Splicing is means that's the built up section. There is no doubt at all. And even this plate gutter or gantry gutter, these are all built up section. Directly, those are not rolled sections. Please understand. If I want to achieve a length of 20 meter, so please maybe 1 second. Let us suppose this is the length of the plate girder. I want to get a length of the plate girder is 20 meter, dear brother. 20 meter length of the plate girder. But if you see the Indian mills, from Indian mills at max, the length of the flange plates are web plates that are available in market are 6.5 meter only. 6.5 meter flange plate and 6.5 meter web plate. These type of lens are only available in market. Okay, so if I want to join, this is the web plate, this is the flange plate. To achieve a length of 20 meter, I need to join these types of different plates. How I will join? I will join with the help of butt connection. I will not lap, brother, dear, I will not lap. Here this is the, maybe I hope this is one plate na, this may be another plate I will take. This may be another plate I will take. Two plates are kept side by side, and then I am going at the top with the help of if I want to go for bolting, at the top I will go for a cover plate and I will do the bolting or riveting. If I want to go for welding directly, I will do the butt weld between this flange plate and this flange plate. If I want to go for welding between these web plates, I will do the welding between this web plate and this web plate. So this splicing is nothing but joining, brother. By the time I am joining, I am general taking this but connection, not the lab connection. But connection I am using. Okay. So moving to this question, this answer is B. Okay, moving to another question. So can you see this question? The forces acting on the web splice of the plate gutter. What are the forces that are acting on the web splice of the plate gutter? Just like as Sumit Saha is saying, so what are the forces that are acting on this web splice? So can you tell me what are the forces that are possible on this web splice, brother? So if you take splicing of web, will resist shear force. Let us suppose this is an I section, bros. This is the gut, and that web splicing is happened. Web splice has got happened. Maybe here I can take. This is how the in between the web splice has got happened. Web splice has got happened. Here I had gone for this welding and all this stuff. I mean, not welding. It's this bolting I had gone for. This is web splicing, which has got connected between two webs. Okay. Right. Now the question is, now when the loads are applied here, this web splicing is subjected to shear force. When the loads are applied, this entire beam will be under bending action. Where it is under bending action, if you can see, the top level of this splicing is under compression. The bottom level of the splice is under tension. That means that in addition to shear force, that web splice is also subjected to some sort of bending in nature, isn't it or not? So I can say the splicing of the web is designed for both for shear force and bending action. So bending, because of this bending, here bending compression is possible and here bending tension is possible, right? So can I move to the next question, brothers? Right? Moving to the next question. I hope you are able to see this question. The intermediate transverse stiffener is needed in plate gutter. When intermediate transverse stiffness means vertical stiffener. When the intermediate vertical stiffener is required, brother. When the intermediate vertical stiffener is required, when D by TW is more than 85, then vertical stiffener is required. This is as per old code of practice. As per new code of practice, when d by tw is more than 67 times of epsilon and the value of epsilon is 1, in such case, by the time I can clearly say, like, in such case I can say this is as per new code of practice. As per new code, vertical stiffener is required. So directly I can say here, as the options are given as per old code of practice, directly I can pick option A, where D is the depth of the web and TW is the thickness of the web plate here, right? So can I move to the next question, bro? So if you please excuse me, can I move to the next question? Right? Moving to the next question. Right. So can you see this question? The economical depth of plate gutter. What is the economical depth of plate gutter corresponds to? What is the economical depth of the plate gutter? It is the depth at which the self weight is minimum. Self weight is minimum. When self weight is minimum, I can also say like cross sectional area is minimum. Self weight is minimum means I can say minimum weight, right? Minimum weight. So what is the economical depth? Answer. So economical depth of the plate gutter corresponds to self weight is minimum, which is minimum weight or minimum cross sectional area. There is no cross sectional area option is there. Only weight option is there. So I can say option A itself is the correct option. Is that okay, dear brother? Vineet Shukla or any other person who are on the online. Is that okay? Can I or all the brothers who are on the online? Okay. Can I move to the next question? Yes, moving to the next question. Right. I hope you are able to see this next question, brother. Shear buckling of web in a plate gutter is prevented. How the shear buckling of the web? That means buckling in web. How the shear buckling of the web in the plate gutter is prevented. How we can stop the shear buckling of the web? I can say by using vertical stiffener. By using vertical stiffener, I can say shear buckling of the shear buckling of the web can be prevented by using vertical stiffener. Shear buckling of web is prevented, right? So I can say the correct option is by using vertical stiffeners. Na? So I can say by using, I can say vertical intermediate stiffener. So I can say directly A. A option is by using vertical stiffeners, we are able to stop this shear buckling of web. Coming to buckling, there are two types of buckling. One is uh, shear web buckling. Second one is uh, horizontal buckling of web due to compression force. Horizontal buckling of web in compression zone due to bending action. Due to a bending action, compression force will come into picture. Na? To stop this shear web buckling, we generally provide this vertical stiffeners. If there is a chance of this horizontal buckling in web is also possible because of bending action, in such case I need to provide this longitudinal stiffeners, longitudinal or horizontal stiffeners, right? So for this question the perfect option is option A. Can I move to the next question, bros? So moving to the next question. So moving to the next question, consider the following statements. Bearing stiffeners are provided in a plate gutter. Bearing stiffeners are provided in a plate gutter. Okay. I hope you know the bearing stiffeners. Bearing stiffeners are vertical stiffeners indirectly. But vertical stiffness, I can say end vertical stiffeners. End vertical stiffeners are provided in plate gutter to avoid local bending failure of the web. No, no, no. To prevent buckling of the web. Yes, to prevent buckling of the web. This is correct. To strengthen the web. Yes, also to strengthen the web. I can say. Right. So these two and I can say this end vertical stiffener in addition to these two, and it relieves the other way. Why this way? Bearing stiffeners are required. First one is to prevent buckling of the web. I can say shear buckling of web. Shear buckling of web. And second one is to strengthen the web. And there is third one option is there. That option is not given. That option maybe I can say next one. That option is that end vertical stiffener the rivet relieves the rivets connecting the flange angles and web from vertical ones. This option is not there. She has these options that are matching here are only second option and third option. So directly I can pick option B. B for Boston is the correct option. So shall I move to the next question, bros? Moving to the next question. So can you see this question? For a welded plate gutter with vertical stiffeners, what is the maximum depth of the web provisionable in design? when the thickness of the web plate is 5 millimeter. So when I use, they are saying with vertical stiffness. With vertical stiffness, what is the d by tw? Where the minimum d by tw should be more than 85, and d by tw should be less than or equal to 200. So d, depth of the web minimum, I can write it as 85 times of thickness of the web. Thickness of the web is 5 millimeter. Na 85 into 5. Depth of the web, minimum depth of the web should be 425 millimeter. But here the question is not about minimum depth of the web. I hope you can see it is asking about maximum depth of the web. So the depth of the web that I will work out from this class will be the maximum depth of the web. So depth of the web maximum should be less than or equal to 200 times of thickness of the web. The thickness of the web plate is given as 5 millimeter. So it should be less than or equal to 1000 millimeter. So in such case, the depth of the web should be more than 425 and should be less than or equal to 1000 millimeter. So I can say the maximum depth that of the web that I can go for is 1000 millimeter as per old code of practice. Even as per new code of practice also the same thing, right? So this is as per old code. As per new code, for vertical stiffness d by tw, this value is greater than 67, and d by tw, this value should be less than or equal to 200. So from this one also, the maximum depth of the web, even as per a new code of practice also, the maximum depth of the web should be less than or equal to 1000 millimeter only. There is no doubt at all. So I can say I can pick option B for Boston is the correct option. Shall I move to the next question? Right? Moving to the next question. I hope you are able to see this question. List 1 contains some elements in the design of simply supported plate cutter. Simply supported plate cutter. Some of the elements like flange splice, web splice, bearing stiffeners, horizontal stiffeners. Okay. And list number 2. Use some qualitative locations on the gutter where these flange splices can be located, where it cannot be located. So like that, I need to match the following. So match the following. Before I look at this one, I just want to say like the flange splices. The flange splices will take care of bending moment, right? So I can say where the bending moments are high at that points, this flange splicing shall not be done. So flange splicing shall not be done at maximum bending moments. What is the maximum bending moment location for simply supported girder? This flange splicing shall not be done at midspan of the simple supported beam, right? I can say should not be done at maximum bending moment at midspan. So I say should be done away from the center of the span, isn't it or not? Should not be done at the center, but can be done away from the center. So I can say can be done, this flange splicing can be done away from the center. Okay, right. So coming to web splice, this web splice will take care of I can say shear force. And coming to this shear force, the shear force is maximum at the ends, right? So I should not do web splicing at the ends. If I do web splicing at the ends, I need to go for higher cost of rivets, especially for this web splicing, right? The cost of that web splicing will be more if I had done the web splicing especially at the ends, right? So I can say this should not be done at the supports. Shouldn't be done at supports. In other words, I can say this web splicing should be done away from the support, isn't it or not? Should be done away from support. Should be done away from support. So I can say flange splice, I can say can be done away from the center. Is that say away from the center of the span? Yes, I can say A stands for this 2, and B stands for this away from the support. Now B stands for this 3. Okay, so coming to bearing stiffness. So what this bearing stiffness? This bearing stiffness are vertical stiffness at the ends. So I can say bearing stiffness are vertical stiffness, end vertical stiffness. So where this end vertical stiffness are provided? The end vertical stiffness are provided at supports, I can say. So I can say bearing stiffness are provided at the supports because these are end vertical stiffness. So directly I can say at supports. This is the way. Now coming to horizontal stiffener, where this horizontal stiffener is provided, the horizontal stiffener is provided longitudinally in somewhere in the compression flange only, because this horizontal stiffener will take care of to resist the horizontal longitudinal buckling of web. Horizontal stiffener takes care of longitudinal buckling of web. Okay, sir, how I increase the torsional stiffness of a beam? Okay, will it be better in a composite built up section or a single rolled section, welded or bolted section? Dear brother, when it is a composite section, what is shear flow resistance in the built up section? Dear, the shear, okay. I can say like, dear Suman Sahar, Sumit Sahar, if you want to achieve torsional stiffness of a beam, then to achieve torsional stiffness of a beam, the code says is, it's not told by me what the code has mentioned. Let me say the same thing with reason. Okay, the code says is, of course, before I say this one, let me complete this question. So here this will be, this option for D is definitely 5. In this case, the option, the correct option that I can pick is for 154. Directly I can say the option A. Now coming to the question of our Suman Saha or Sumit Saha. Okay, one second. Suman Saha question is, sir, how do we can increase the torsional stiffness of the beam? The torsional stiffness of the beam is increased by increasing moment of inertia I about ZZ axis is increased, and I about YY axis is also increased. About both major axis and minor axis, if the moment of inertia has got increased. To increase the moment of inertia, especially if it is a plan, if this is the plan, this is the web. If this is the web, what the code says, especially in case of this composite plate gutter, especially in case of composite plate gutter, about this is the axis. Generally, if I provide this moment of inertia about x-axis is always there. When you are providing this vertical stiffener, these are the vertical stiffeners with, this is in plan, this is web, this is web, this is in plan. When you are able to provide these vertical stiffeners with proper spacing, with spacing something like the spacing is less, is greater than d by 3 and less than or equal to, I can say 1.5 times of d, and this is the outstand of the stiffener. If you are doing providing this outstand of the stiffener, which we call it as BS, is 20 times of thickness of the TQ, 20 times of TQ, thickness of the stiffener. Here also this is outstand of the stiffener. BS stands for 20 times of TQ. When you are providing this minimum, when you try to provide the spacing of these vertical stiffeners very close, such that it is more than 2d by 3 and less than, and if you provide in this way, if I increase the moment of inertia about this axis, because torsion means that it will get buckled about this axis. This is the axis about which torsional buckling takes place. In order to stop that torsional buckling, the code says is either provide this vertical stiffeners in this way, or even after the provision of this vertical stiffeners also with spacing less than d by 3, In such case, I need to provide a horizontal stiffener in the form of angle sections. If you are able to provide this vertical stiffeners and angle stiffeners such that when the moment of inertia of the stiffeners is more than some value which is prescribed in code of practice, if you are expecting me the code of practice class, right, especially the minimum moment of inertia of the stiffener when this ISC is greater than or equal to 0.75 times of d times of TW cube. If you are able to achieve this moment of inertia of the stiffness, IS stands for moment of inertia of the stiffness. If you are able to provide this moment of inertia of the stiffener, then in such case the torsional resistance will be high. This is how the code is asking us to provide the minimum moment of inertia for both for vertical stiffeners and for horizontal stiffeners. If you are able to provide that one, definitely the beam, that girder or whatever that may be, it is good with respect to torsional stiffness. You need to satisfy this minimum moment of inertia of transfer stiffener condition, right? This is one thing. And you are saying like whether it is good by taking in the help of composite built up beam. It is with the help of built up beam, it is with the help of built up section, it is better. I cannot say composite. It is a built up section is a better one. You cannot composite means you are talking about maybe the flange maybe one material, web maybe another material. No, no, no. All the material should be used as steel, but it should be a built up section, no doubt. Built up section is far preferable, brother, because in case of built up section, you can provide whatever may be the depth of the web, whatever may be the width of the flange, whatever may be the thickness of the flange, everything you are able to do. In such case, the design is very simpler. In case of this built up section, if you want to achieve certain minimum moment of inertia with the help of stiffener, the code asks us to provide this is the minimum moment of inertia I need to provide, right? Shear flow, shear resistance in built up section, shear resistance in built up section, dear brother, one second. Now coming to shear resistance in built up section, if this is a built up section, brother, this is the built up section, and you can say like this is how the angle section is. This is built up section. Please understand, this is not a composite material, this is a built up section. Composite section means when the materials are of different, like just like that of RCC, that is a composite section. This is a built up section, but it is made up of same material. When it is made up of same material, here the flow, the shear stress flow is just like when it is a single built up section. I hope you know from the fundamentals of what I can say, from the fundamentals of strength of materials, you can directly sketch the flow of the shearing stresses in this way when there are no stiffeners are there. But after you provide stiffeners, maybe like this, when you had provided some stiffeners are there, like this in this way, like this in this way, the total section is almost acting like a rectangular section. In such case, the shear force, shear variation will be in this way. This is with stiffeners. Dear brother Suman Saha, there is a lot of things you mentioned like composite. Composite is a terminology that should come into picture when two different materials are used. But here we are using one material. You should not use the terminology composite. Composite is the terminology that you need to use for RCC. Okay, right. For in case of RCC, if you see, this is RCC with bars. If you take for RCC with bars, this is how the variation of shear stress may be. And the tensile concrete in tension zone is neglected na. So hope you are able to see this is the way of shear flow, shear stress variation across the depth. Is that okay, Suman Saha? Right? So had I answered your query? Right? Let me rub the screen, brother. So for this one, this option is A. I already mentioned you this answer, right? So can I move to the next question, brothers? So moving to the next question. I hope when you see this question, the horizontal stiffener in plate girder. What is horizontal stiffener in plate girder? The horizontal stiffener in plate girder is useful to stop longitudinal buckling of web due to bending compressive forces. right? So this is how we can say. So what is the correct option that we can say is used to safeguard against compression buckling of web plate? Yes, this is the buckling of web plate, longitudinal buckling of web plate that is arising because of bending compression, right? So this option A is correct one. Shear buckling of web plate. This shear buckling of web plate is taken care by this vertical stiffness, right? So I can say correct option is option B for Boston is the correct option. Shall I move to the next question, brother? Vinit Shukla or all the persons who are on the online, can I move to the next question, bros? Moving to the next question. The minimum thickness of the web in the plate gutter. So minimum thickness of the web in the plate gutter when the plate is accessible and also exposed to weather. So when the plate is accessible to paint, when the plate is accessible to paint and is exposed to weather, in such case I can say what is the minimum thickness of the web as per IS 800. The minimum thickness of the web plate for not only for web plate or flange plate, anything, the minimum thickness of the element if it is accessible to paint and also exposed to weather is 6 millimeter. 6 millimeter is the answer when it is accessible to paint and expose it to weather. When it is accessible to paint and not exposed to weather, in such case the minimum thickness of any structural element is 4 millimeter, and the answer is 8 millimeter is the minimum thickness of any plate or any structural element. I can say when it is when it is not accessible, it is not accessible to painting and exposed to weather, in such case it is 8 millimeters. As per the condition, I can say B for Boston is the correct option. This I already talked at the time of part 2 also. This class I had already discussed. IS 800, summary of IS 800, especially in part 2 had discussed this class. Okay, shall I move to the next question, dear Suman Saha or any other person who are on the online? Can I move to the next question? Okay, moving to the next question or next class, I can say, right? So can you see this question? The web crippling, that is web bearing failure due to excessive bearing stress can be avoided. How this web crippling can be stopped? The web crippling can be stopped by providing by increasing the length of the bearing plates. Yes, by increasing the length of the bearing plates we can do. I hope if you know the web crippling strength. What is the web crippling or web bearing strength? The answer is B plus. In terms of new code of practice, the answer is B plus 2.5 times of thickness of the flange plus root radius into thickness of the web. This is bearing area, web bearing area into bearing stress. What is the permissible bearing stress as per new code of practice? Fi by 1.1. This is as per new code. Coming to as per old code. As per old code, it is B plus, I can say, root 3 times of thickness of the flange plus root radius, I can say, into TW, thickness of the web, this multiplied by permissible bearing stress. The permissible bearing stress is 0.7 times of Fy. This is how we can work out as per old code. In old code or new code, the common platform, the common thing is I can increase the bucklings, I can increase the crippling strength by increasing the value of B. What is this value of B? B stands for increasing the width of bearing plate or length of bearing plate. By increasing the web, by increasing the thickness of the web, I can say the web crippling stress due to excessive bearing can be avoided. I can say like it can be avoided by increasing. I can say like by increasing the length of the bearing plates and by providing suitable stiffeners. Yes, this is also correct. I can say even increasing the thickness of the web. By increasing the thickness of the web also the crippling strength is increased. Yes, A is correct, B is correct, C is also correct. I can say this is not none of the above. It's a typo error. All of the above. So I can say A, B, C, all these are all correct now. So directly I can pick. I may say A option, B option. A is correct, B is correct, C is correct. So I can go for directly the option called as D for Detroit. All the above are correct. So I can say this D, all the above are correct in in stopping this web crippling failure. Can I move to the next question? Yes, moving to the next question, bros. I hope you are able to see the next question. The intermediate vertical stiffeners are provided in plate gutter. Where this intermediate vertical stiffeners are provided to stop what? To stop shear buckling. To stop shear buckling of web. To stop shear web buckling. To stop shear web buckling means to eliminate web buckling, right? The correct option is option A itself is the correct option. Is plate cutter to transfer concentrated loads? No, just to not to transfer the concentrated loads, brother. To not to eliminate, to I can say to eliminate web buckling. That is the correct option, right? Moving to the next question. I hope you are able to see. This is not 1/10 I can go for. This is maybe 1/20th. Right. So what is the depth of the plate cutter for long spans? The depth of the plate cutter for long spans, I can say depth of the plate cutter for long spans will vary from 1/8th of the span to 1/12th of span. So this is the this is the depth of the plate cutter. Generally, as a thumb rule, generally we can take care. Instead of economical depth, we can take the depth between this span by 8 to span by 12 for plate cutters of long span. So generally for long span means when the depth is when the length is more than 20 meter, we can write that we can use this formula. In such case, the correct option is from 1/8th of the span to 1/12th of the span. So which is the option is generally I can go for it is option C. So shall I go to the next question? Yes. Oh, sorry. So by this we had completed for today's session and it is almost 2 hours. So please excuse me. I need to stop this session by this time. Before I stop the session, I just want to convey if you are a serious aspirant of GATE or ESE or any other competitive examination, brother, then in such case I can recommend you guys to join the paid course by using this code VT10 in Unacademy Plus platform. To join in paid course, you need to install this Unacademy learning app. So install that Unacademy learning app and you are able to follow me by using this link which is given below, right? And I just want to convey coming to the financial terms. If the subscription for 1 month subscription to 12 month 24-month subscription, if you want to get 10% discount every time, you need to bound to use this code VT10 for any of the subscription for 1 month subscription to 24-month subscription. If it is a 12-month subscription, the cost for 12-month subscription is 27,225 in an Academy Plus platform. In for 24 months course, the cost after 10% discount is 39,600 after 10% discount. For I can recommend this 12 months course for the students who are in final year, whereas I can recommend this 24 months course to the students who are in second year or third year. I can recommend this course, right? Every day my class is happening in Sanacad in this Let's Crack Gate and ESE Civil YouTube channel. Every day my class is happening by 11 a.m. So I can say like you can come down to my class every day by 11 a.m. And I can recommend Kamalakar sir Pandey's class also. Kamalakar sir Pandey's class is happening every day by 9 a.m. I can recommend even Kamalakar sir's class also for you guys who is teaching transportation, surveying, non-structural subjects, right? And You are getting all this for free of cost. Please inform the same thing to your friends so that they will also get benefited, right? Please raise a thumbs up. So please raise a thumbs up. Please share this video, like this video, subscribe to our channel. Let's crack GATE and ESE Civil YouTube channel. If you subscribe to this channel, definitely you will not miss even a single video that is coming out from this channel. So please subscribe for this channel so that you will get more free content also. And please raise a thumbs up. Please, for you guys, I already started a Telegram group, and the name of the Telegram group is Unacademy _ Civil Engineer Tilak. You can use this channel. If you come down to this channel, if you want to post your doubts in this channel, you use this link which is given below. If you use this link which is given below, you will be redirected to my Telegram group. I will take care of your doubts if you have any. You can post your doubt directly in the Telegram channel. And the another Telegram channel officially by Unacademy is this one and this one also. Okay, use these two channels of Telegram to get subscribed. Okay, right. Thank you. End of the session.